Hello Internet, Zach here, and welcome back to Collecting the Elements. In this episode, I'm going to be taking the advice of some of my viewers and extracting element number 73, tantalum, from some capacitors. Tantalum is a rare, hard, dark gray metal. It has the 5th highest melting point of any metal on the periodic table, and it's one of the 6 special metals that can be anodized to have bright, shiny colors without requiring any dyes. It also has the strange distinction of having the longest-lived nuclear isomer of any nuclide on the table, tantalum 180M. It's a metastable excited state of tantalum 180. While tantalum 180 is quite unstable and decays very quickly, tantalum 180M has never been observed to decay, unlike every other nuclear isomer out there. Anyway, tantalum finds use mostly these days in capacitors and high-temperature alloys. Historically, it was used as light bulb filaments before we figured out how to use tungsten. And I'm going to be getting my tungsten sample from capacitors today. So let me show you how I did that. Here I have the 3 biggest tantalum capacitors that I could find at Fry's Electronics today. Inside is a little piece of sintered tantalum metal, which is metal powder that's been compressed into, in this case, a cylindrical shape, and then compressed very tightly and heated up so it becomes a porous piece of metal, basically. So the first step is to get that out of the inside of this capacitor. That is the little bead of sintered tantalum metal. It's not very big. Huh, and this one's actually not a cylinder, but a cube. Isn't that neat? Well, this second one's kind of disappointing because that was a lot of packaging for a very small bead of tantalum. I wonder if this third one's going to be just as bad. Looks like it. Well, that one's a little bigger. Three tantalum beads of various sizes. This is one of the chunks of tantalum, and it's kind of covered in various gunk that actually makes it work as a capacitor. So I'm gonna do my best to file that off. Okay, you might be able to see some shiny spots starting to show up. That's where the metal is starting to be exposed. There we go. That's some shiny tantalum metal. And I'm going to file off all of the other sides to get all of the gunk off. So that way there's as much visible, shiny tantalum metal as possible. So what I want to do with these tantalum pieces is anodize them and turn them pretty colors, much like I can do with niobium, vanadium, titanium, zirconium, and hafnium. So this is a niobium test piece that I used to test the anodizing bath, and yeah, pretty colors. Anyway, I tried this with one of the tantalum chunks, and it didn't work. I think there's still too much gunk stuck between the tantalum particles. So what I'm going to do to try to clean up the gunk is let it chill out in some hydrochloric acid. Because a large component of the gunk should be manganese dioxide, which will react with the hydrochloric acid and go into solution. Hopefully, if I let these sit under hydrochloric acid for a while, I should have some nice clean tantalum left and the gunk should be gone. Yeah, you can probably see the acid is already starting to turn brown, so it's definitely dissolving something out of there. I've moved the tantalum pieces soaking in hydrochloric acid into a test tube. You can probably see them in there. And I've changed the acid a couple of times because it keeps turning really dark brown. So I'm going to pour this into my cup of manganese salts from my experiments trying to extract manganese, because this should be mostly manganese chloride. Now I'm going to put some fresh acid into the tube. And I'm going to keep repeating this process until the acid stays clear. Here I have one of the small samples of tantalum. And here I have my anodizing bath, which is just a little bit of distilled water with 3 drops of sulfuric acid in it. I have my voltmeter over here with the voltage that's being used to anodize the tantalum. So I try to very carefully dip the tantalum in here without getting the alligator clip in. Notice the voltage drops a bit. Now it hasn't picked up much color, so I'm going to raise the voltage. Okay, let's see if the camera picks it up. Probably I can see some hints of blue and green in there. Raise the voltage some more. Oops. And if I accidentally touch the solution with the alligator clip, there's a bunch of fizzing and bubbling. It's actually really difficult to get a good grip on the little tiny wire that's stuck to here. See if you can see that on camera. It's picked up a lovely shade of blue. And this side's gold. Let's up the voltage a little more. The blue's gotten really pale. The blue's gotten even paler and almost disappeared. Okay. I'm seeing a bright gold color that I'm hoping the camera's also seeing. Yeah, these batteries are getting really run down. The batteries are actually getting run down enough that I'm having trouble staying over 50 volts. So, I'm going to show you the test piece that I did earlier. This one I anodized all the way up at 83 volts when the batteries weren't quite as dead. And I'm hoping the camera shows you the lovely shade of pink that is. So we have a pink one and a gold one. And maybe I'll just leave this one its normal. That one looks blue on camera. Okay, so we have a pink one, a gold one, and a blue one. And that's my extremely tiny tantalum sample. So let's get this into a test tube. Okay, normally on this channel, when I make an ampoule, I'll round off the bottom of the test tube the best I can. This one I decided to leave pointy because the sample of tantalum is just so tiny that in a round test tube it would disappear. In a pointy test tube, at least you can still kind of see the tantalum bits. So here it is, by far the smallest element sample on my table. But it really wasn't in the budget to get a whole ton more capacitors to really fill this up. Anyway, I hope you enjoyed this video. If you did, hit the like button. If you want to see more, hit the subscribe button and ring the little bell over here. And if you know someone else who would enjoy this, share it. Anyway, if you want to help me make more videos, throw me a few coins on Patreon or PayPal. Links in the description. And I'll see you next time.